So, okay. Um, I am taking this class, the Primogens Rust for TypeScript Developers class. And yeah, I am in my code, I have just a directory called Rust TypeScript. And he's gone over some iterator stuff, and I've kind of made a mess of some code. Took some notes, but it's kind of like combining several lessons into just this high level like iterators. I'm doing the same thing with enums. It's kind of like the next big section, and he's getting about enums basics, and then now we're getting into options and stuff like that. Super cool, but just trying to organize my code correctly using Rust. And one thing that I recall in the past, super cool video. Let me pop this up in another one. This
Hey guys, welcome back to another Rust tutorial. In this video I'll be talking
Jeff Nojow modules pub and use this. I think this was really helpful. I'll put a link to this one. And then another, oh wait, sorry, wrong one. This one. Close this as the same video. This guy.
Let's talk about Rust packages, crates, modules, and workspaces.
Yeah, this stuff is cool. Let's watch this together.
You can think of this floor as a workspace. And on my workspace, I can have multiple packages. Each one of these boxes is a package. Inside the package is this crate. This crate is this cardboard tray that the cold brew coffee's in. And inside the crate is the cold brew coffee, which you can think of as modules. This crate has some modules. So the workspace had a package on it. Package had a crate in it. Some boxes have multiple items in them. The crate had potentially multiple modules in the crate. Let's talk about crates, packages, modules, and workspaces. Now these are really closely related concepts that have subtle differences. When you run cargo new on the command line, you're actually creating a crate and a package. All cargo.toml files are associated with either a package or a workspace. So a cargo.toml file in a package applies to all the crates in that package, and a cargo.toml in a workspace applies only to that workspace. Workspaces are used to group related packages that may or may not depend on each other.
May or may not depend on each other. So like, for example, if I'm just trying to keep my notes, like my repo, fairly organized, I could, in theory, have a workspace, and then I could have a package for iterators. So like convert this thing into a package. Okay, and I did cargo new for this, so it has its own, so it's a package. Yeah, and then maybe here's like another package for enums and do things like that. Okay, cool.
Each other. One example of this might be a web application that has separate packages for the front end and the back end. All packages in a workspace share a common output directory for build artifacts.
Wait.
All front end and the back end. All packages in a workspace share a common output directory for build artifacts.
Oh, all packages in a workspace share a common target debug. So like, when I go over here, these packages right now are self-contained because I'm not working inside of a workspace. Okay, I get it.
Create a workspace by creating a directory and placing a cargo.toml file in it with a workspace section. While you can use cargo new to quickly create the file structure for packages, it doesn't currently appear that you can do so for workspaces. Inside that directory, you can run cargo new to create packages within that workspace. To associate those packages with the workspace,
I see. So let's see if I could do, let's see, make a directory. Let's just break stuff. I have my directory. It's already called Rust TypeScript. And if I want to create a new cd echo workspace 2,
create the file structure for packages, it doesn't currently appear that you can do so.
So I need to create a Cargo.toml at this high level, this root level. Cargo.toml. Bloop. Open this up. Workspace. Yeah. And then I need to add my packages.
For Workspaces. Inside that directory, you can run cargo new to create packages within that workspace.
I didn't do that because I'm adding after the fact, but I did cargo new for the enums and the iterators.
To associate those packages with the workspace, add their names to a list of members in the workspace cargo.toml file. A package.
All right. So now I could do something like members equals, and I should be able to do like iterators enums. Oops. Yeah. Not sure.
Packages with the workspace, add their names to a list of members in the workspace cargo.toml file. A package consists of one or more crates. Crates can either be binaries or libraries. A package can contain at most one library crate and may contain as many binary crates as desired. The default binary crate is defined by placing a main.rs file in the source directory of a package.
So like, all right, let's go to this one that I'm currently working on. So here we are. We've got my enums package, if I'm following this correctly. And I'm putting a main.rs. So this is the binary crate. It's not the library. And you can have as many binary crates as you want, but only one library crate in a package. I gotcha. So currently I would say this is just a single binary crate in my enums package.
Default library crate is defined by placing lib.rs inside the source directory of that package.
So, yeah, this is very common in like Solana projects.
Additional binary crates can be added to the package by placing them in a bin directory within the source directory. The names of these additional binary crates will be dictated by the name of their root source file.
So hang on. So
the source directory. The names of these additional binary crates will be dictated by the name of the root source file.
Okay, so the name of their root source file should be enums, I think. So watch this. So if I go, so like back to this is the course. I'm not going to share. Not supposed to do that probably, but here we are. I'm taking the class, working through it, and here he's been talking just high level like enums and stuff, but then he's starting to get into options. And I'd like to, keep the code somewhat clean, or at least separated, then left arrow. All right, so if that's what I'd like to do, high level enums, I've kind of covered some stuff in here. Yeah. What I'd like to do though is inside, he's saying, back to the video,
within the source directory.
Within the source directory, if I go, let's add in a binary directory, and this time I had this new file. I'm going to go ahead and just call it options.rs. This is a crate, if I'm understanding this correctly. Okay. Oh, look, I added that, and all of a sudden I'm starting to get some new stuff added. Target, yeah, like at the high level in my folder. So for example, if I do CD, oops, I didn't mean to do that far. Rust TypeScript. Okay, if I do tree, what happened? Ooh, yeah. All right, let's do tree level 3. Okay. Yeah, like we have our root. We have this root Cargo.toml that I just created, right? And then I said I have member packages called enums and iterators. Those are two separate packages, not terribly related to each other. It's just for this class that I'm taking. And then inside of the packages, they have their own source, their initial like binaries. Iterators, I didn't do anything, but for enums, I've just created this binary subdirectory and added this new options binary. Okay. So let me see if I go back to, this is the root Cargo.toml. Okay.
The names of these additional binary crates will be dictated by the name of the root source file. When working in a package that has multiple binary crates, use the -- bin argument when invoking cargo run to specify the name of the crate you'd like to run. The binary.
Okay. So if I'm understanding this correctly, I open this up. Okay. And I'm guessing it's just like function main. What's the syntax? Yeah, it's just function main. Okay. Didn't know if it had like some specified like result in the Solana anchor program. So if I just do print line hello from options binary crate. Can I do that? And now, if I'm understanding correctly, if I let's go back into enums. Again, I have tree source. It looks like this. So I've got my main.rs is my initial kind of primary binary crate when I did cargo new. But now I have this this additional binary in this enums package. And so if I want to run it, so he's saying I could do cargo run and then specify bin for binary. And which binary do I want? I want the options. Yeah, options. I don't have to specify the .rs. I hit enter. Yeah, it compiles, and there it is. Hey, hello from options binary crate. Look at that. That's cool. It's the little things. All right, let's keep going.
Binary crate defined in main.rs can be referred to using the name of the package. Use the dependencies section of a package.
Wait, what? Hang on. Got a little distracted there. The ADD kicked in. All right. Let's go back just a second.
When invoking cargo run to specify the name of the crate you'd like to run. The binary crate defined in main.rs can be referred to using the name of the package.
Oh. So the binary crate in my main.rs, so rather than just doing cargo run, which will do whatever, cargo run could not detect which binary to run, use the bin. Oh, okay, so, but if I do cargo run bin, and then he said I could use the name of the package, which should be enums, right? That should work. Yeah, that's running that. Okay. Okay. But I can't do... Well, okay, that makes sense, because I didn't... I mean, can I just do cargo run main? Oh, available binaries. There it is. Thank you, cargo. Available. So I have to... all right. Yeah, so it is the cargo run and then do the binary flag with back to options. And there it is. I gotcha. Super cool. Super cool.
Use the dependencies section of a package Cargo.toml to specify the library crates that the package depends on. These dependency crates can exist in the Cargo package registry, in a GitHub repository, or in another package of the same workspace. Each crate contains...
Or in another package of the same workspace.
In a GitHub repository, or in another package of the same workspace.
Of the same workspace. So he's basically saying, in this workspace I have that I just created, I have my members, iterators, and enums. If I wanted one package, if I wanted enums to be able to work off of or use something in my iterators package, then that's when I could do dependencies and specify. It would be like iterators equals, and then like the path equals the path to my directory. I gotcha. Neat.
Space. Each crate contains one or more modules. Modules provide logical groupings of functions and structures, as well as control over whether those resources are exposed to other modules. Modules can be defined purely in code by enclosing the contents of that module in curly braces, or they can leverage the file system to establish a hierarchy and separate the code into multiple files. Declare the existence of a module in a separate file by placing a semicolon after the mod clause instead of curly braces. The Rust compiler will look for the module in an RS file that matches the module name. You can define submodules in this file, which refer to files inside a directory named after the module. Hope this overview of crates, packages, modules, and workspaces was helpful. See you in the next one.
Yeah, that was helpful. I didn't get into the submodule stuff. I technically could. But I think for my purposes, just the idea of like, hey, you know what, I could continue this class. And rather than like screwing up, and I take notes and stuff like that, just trying to follow along. I could have this fresh file, but it's all nicely contained in this enums package or directory. For my purposes, just because, I don't need to do like a cargo new like project, a new, I don't need to create that many for every single little miniature lesson or video that he covers, So, yeah, that was cool. Educational for me. Hopefully that was for you. Okay, so before signing off, I thought might as well circle back to modules. In my Rust class, it doesn't really suit my case, but I have worked with modules, and this is kind of, as I'm slowly connecting the dots between this stuff. In my on the right, I've got an example project from my blockchain series where we create on the Solana blockchain a ledger program. It's just kind of storing accounts, and I use it to keep track of my boys' like allowances. It's just, why not? And anyway, one of the patterns that you'll see with Anchor programs or Solana programs that use the Anchor framework is you'll have a new program when you first initialize it, like Anchor init, and then you'll give it a name. So in this case, I've given it Ledger, and inside this really is kind of like a package, right? So the package name is the name of the, what I just called it. You have some dependencies. Obviously, there's a lot more to it. It also has, this is one of those cases where this is a library crate. So the package has a single library crate, which in this case is lib.rs, which there's a lot to it. It's a module ledger, so it's kind of treated as a module. This is kind of some of the inner workings with Anchor. That said, inside I have this library crate, kind of represents my package, I guess. But then for modules, you create a directory. So watch this. We'll recap this one more time and kind of connect some dots, hopefully.
Each crate contains one or more modules. Modules provide logical groupings of functions and structures, as well as control over whether those resources are exposed to other modules. Modules can be defined purely in code by enclosing the contents of that module in curly braces, or they can leverage the file system to establish a hierarchy and separate the code into multiple files. Declare the existence of a module in a separate file by placing a semicolon after the mod clause instead of curly braces. The Rust compiler will look for the module in an RS file that matches the module name. You can define submodules in this file, which refer to files inside a directory named after the module. Hope this overview of crate
So,
in this file, which refer to files inside a directory named after the module.
all right. So, following that bit of logic, the library, if I go to my library file, use instructions public module state, which again corresponds to the folders that I've created. So I've created these kind of folders for modules. The instructions module has a bunch of different, I guess you could call them submodules. And one of the patterns you see is a bunch of submodules, kind of like an index.ts. Like if you have a bunch of different files and you want to just tidy them up, you can put them into a individual mod.rs file, something like this. So you're kind of like importing them and then making them available. Public use. That's how I'm understanding it. And then same with state. It's another module, and inside of it, it has its own submodules and whatnot. These are for Solana specific. These are like structs, and getting into implementing some functionality for your Solana account types, your data accounts and whatnot. Entry, ledger, and then here again, mod.rs. This is just kind of convention where inside of your module, you tidy them all up into a single mod.rs. Yeah. So I think that makes sense. And then if I go back back into my library, my lib.rs, remember you can only have one, lib.rs library crate or library binary or crate inside of a package. And here I am bringing them in. Public mod instructions, public mod state, making them available so that I can use them directly inside. So this is kind of a working example that I personally have worked on and starting to connect some of those dots. But hopefully this was helpful. It's good for me. I have to continue doing this again and again until it becomes really soaks in. So, all right. Cheers for now.